All right, welcome to 3.2 video review. Today we're going to be talking about reciprocal functions. We're going to be specifically talking about models that use inverse variation and how we can move those graphs around. So, functions that model inverse variation have the form f of x is equal to a over x, where x does not equal 0. X can't equal 0 because if x equaled 0, we'd be dividing by 0, and we don't ever want to divide by 0. So, a divided by x. They belong to a family whose parent is the reciprocal function. Which is f of x equal to 1 over x, where x is not 0. The parent function of the reciprocal function is what we just said. It's f of x is equal to 1 over x, where x does not equal 0. The general form of this is a little bit bigger. That's going to be f of x is equal to a divided by x minus h plus k, where x does not equal h. Notice that we're seeing h and k for the second time. The h and k in this case is the same h and k that you had when we were talking about quadratic functions, specifically in the vertex form. The h and k here has the same meaning as well. It's going to shift us around in exactly the same way, and we'll talk about that when we get down to translation. Before that, we're going to talk about how a affects our graph. So you see that y is equal to a over x. The only thing that we have here that's going to adjust how our graph looks is that a. So what happens whenever we're trying to stretch this thing? That's what happens whenever a, the absolute value of a, which means the positive version of a, is greater than 1. So if the absolute value of a is greater than 1, then our graph is actually going to stretch vertically. So, and then shrinking, if the absolute value of a is in between 0 and 1, and I wrote an a there, I meant to put a 0, 0 less than absolute value of a, which is less than 1. So, for instance, let's say that a was equal to 1/4 or 0.25. That would be between 0 and 1, so we would be shrinking our graph. We'd have a vertical shrink. Again, we're talking about the positive version of this, which is why I put it inside those absolute value symbols. So we could have negative 1/4, and it would shrink the same as if it was positive 1/4. Next thing would be a reflection across the x-axis. This happens whenever the value of a, notice this one is not the absolute value, is less than 0. We would reflect across the x-axis. Translation, on the other hand, notice that our a value here is 1, so we're not actually adjusting the size of the graph, we're just shifting it. The h and the k are the sole effectors of that. And I want you to notice that here we've got this minus right in front of that h. So exactly the same as it was with the quadratic vertex form. Here, if you have a value in the h, you have to flip its sign, and that's going to tell you where to move it. The h value is going to tell you your horizontal movement. Horizontal movement from the origin. So for instance, if I had 1 over x minus 2, we'd be moving to the right 2 units. That's going to give you a asymptote of x is equal to some number. And we'll discuss what asymptote means in just a second. K is going to be your vertical movement. And that's going to be the same thing. Y is equal to blank will be the equation of your asymptote. So let's talk about what I'm talking about with asymptotes. And yes, I understand that it is a funny word and probably something you haven't heard before. Your asymptotes of your graph are going to be the vertical and the horizontal lines that your graph tends toward but doesn't cross in its end behavior. And when we're talking reciprocal functions, you've got two asymptotes. One of them is called the horizontal asymptote. And the other one is called your vertical asymptote. Another key word that you might want to know is that each of these curved lines on either side is called a branch of your graph. So, two new words that we want to keep in our minds as we're moving throughout this lesson would be asymptote and branch.